Hello everyone, welcome to Getson. Myself Kavipriya and this is Sherina. Today thermodynamics two problems பார்க்க போறோம் which are all asked in ISRO and GATE exams. First question பார்க்கலாம். A gas is contained in a cylinder which a movable piston of 100 kilomass. When 2500 joule of heat flow in the gas, the internal energy of the gas increased by 1500 joule. What is the distance through which the piston rises?
So first question, in this let us draw a diagram. It is said that a gas is contained in a cylinder. So we draw a cylinder and now with a movable piston, this is the piston and the piston of 100 kilogram mass. So the mass of the piston is given, that is 100 kilogram, and here gas is filled. When 2500 joule of heat flow into the gas, that is the heat flow is Q is equal to 2500 joule flow into the gas. The internal energy of gas increases by 1500 joule. Internal energy of gas increases, which means delta U is equal to 1500 joule. What is the distance through which the piston rises? We have to find the distance through which the piston rises, that is delta x. We have to find delta x. So from this we will apply the first law of thermodynamics. According to first law of thermodynamics, Q is equal to delta U plus work done on the piston. Since here it is piston, we take work done on the piston. So Q is given 2500 joule and delta U, internal energy, is given 1500 plus work done. So from here we can calculate work done. Work done is equal to 1000 joule. So we got a first value, work done is equal to 1000 joule. Now when we apply a work done formula, W is equal to, we know, force into displacement. So this is the delta x that we are going to calculate, and so from this we get W is equal to, here force, there are two forces here, atmospheric force first one and the force acting on the piston. There are two forces into delta x. So here atmospheric force, since the area of the piston here is not given and the atmospheric force is not given, this we assume to be 0. We assume the atmospheric force to be 0, and so W will be equal to, so W we already found out, so 1000 is equal to force of the piston into delta x. Now the force of the piston, we can see that the formula for force is M into G. So 1000 is equal to M into G into delta x. So what is mass? Mass is 100 kilogram. 1000 is equal to 100 into 9.81 into delta x. So from here we find that delta x is equal to 1 meter. So the option is option B, 1 meter.
Okay, next question பார்க்கலாம். The inlet and outlet of the steam for an adiabatic steam turbine are in the figure. The notations are followed. If the mass rate of the steam through turbine is 20 kg per second, the power output of the turbine is.
So okay, here a steam turbine, the diagram of a steam turbine is given and the inlet values and the outlet values are given. In inlet, enthalpy, velocity, height and pressure, and in the same way in outlet, enthalpy, second enthalpy, the volume of the gas, the outlet, and the height and the pressure, everything is given, and mass flow rate of steam is also given. So here we will apply steady flow energy equation. H1 plus 1 by 2 V1 square plus GZ1 square plus Q is equal to H2 plus half V2 square plus GZ2 square plus W. So we multiply mass flow rate in both the sides. So m dot and m dot, and now when we take it in unit calculation, we get it as H1 plus V1 square by 2000 plus GZ1 square by 1000 to Q, which is equal to m dot into H2 plus V2 square by 2000 plus GZ2 square by 1000 plus W. Here
1000.
Okay, 1000. Since it is adiabatic steam turbine, Q will be equal to 0. And now when we apply all the given data given, m dot is 20 into H1 is 3200 plus B1 is 160 square by 2000 plus G is 9.81 into Z1 is 10 square by 1000, which is equal to 20 into H2 is 2600 plus V2 is 100 square by 2000 plus G is 9.81 into Z2 is 6 square by 100 plus W. So from this, when we calculate this when we do this whole calculation, we get W is equal to 12.1568 into 10 to the power 5 watt. To calculate into megawatt, W is equal to 12.157 megawatt. So option A, 12.157 megawatt.
ஓகே, டுடே வீடியோவில் 2 கொஷின்ஸ் பார்த்தோம். அது இஸ்ரோ கேட்டில் எக்ஸாம்ஸில் கேட்ட ஒரு இம்பார்ட்டன்ட் கொஷின்ஸ் பார்த்தோம். இது அழகாக எக்ஸ்பிளைன் பண்ண ஷெரீனா, தேங்க்ஸ்.
தேங்க்யூ.